We had a ratios question much earlier in this section. I think it was number 9. And during that, it was pretty easy, but I said you got to stay organized. You got to show your work because it's going to get more complicated. And here it's getting more complicated. Because I had a good process for the easy question, I'm very prepared for when it gets hard. So the process for these unit changes is to use fractions and ratios to kind of stay organized. So what are we going to do? We're going to make rates. If you're ever confused by what's going on, there's too much, my advice is to focus first on the question. You're almost always going to be able to turn that into a rate. And when they say how many acres, they're telling us, okay, we're going to need a variable to represent that because we don't know. It's an unknown. So, okay, fine. Let's take a look. So, X acres is equivalent to 48 ounces of graphene. So I'm using both of the numbers to create a fraction, to create a rate, and I write the units because that's the most important thing here. Now, my ideal situation would be that I look at the question and I'm able to pull out another rate that's equivalent, that compares acres to ounces. But that's almost never going to happen as these get harder because we're going to need to convert, but that's okay. All I really care about is that one of the units is the same. So I see right away, okay, I've got acres here. So let's put that 1 1/3 acres on the top of this other fraction. And so now I'm trying to think, okay, well, what is that equivalent to, right? There's some sort of rate, there's some sort of conversion, and I'd love to compare that to some other unit. And in this case, it's a unit, but it's weird. That's a football field. So 1 field. We can do this. This is how rates work. It's just kind of comparing two values. 1 field is equivalent to 1 1/3 acres. So okay, fine. Now, I've got a good thing, which is that I have acres on the top on the left side and on the top on the right side, and that's what I want. I want the units to be the same. But right now, the bottoms don't match up because field is the wrong unit. I want ounces. But that's okay because now I go in and I say, okay, what do I know about fields? I want some unit or some rate that's going to put fields this time on the top so that they cancel out when I have a fraction and I'm multiplying. Something's on the top and it's on the bottom, cancels out. So in this case, they say 7 football fields. Okay, so 7 fields. Okay, I'll just read the sentence. It's so thin that a sheet weighing 1 ounce can cover up to 7 football fields. So 7 fields is equivalent to 1 ounce of whatever graphene is. So that's good for me because it means that now fields cancel out, the same unit on the top and the bottom cancel out, and I've fixed my problem. Now I do have ounces on both the top and on the bottom of both sides. So there you go. When I want to eliminate a unit, I want it to be on the top and the bottom of the same side. When I'm done, I want the same units on the tops and on the bottoms on opposite sides, right? So there's a little confusion there. But the good thing about all this is if I understand this process, I also am going to understand every single ratios units question I get because the process keeps me organized. No matter what story they throw at me, I'm going to be ready to put the numbers in the right places. And so the final step here is to just solve. The units no longer matter because the units have already kind of done their job. So I'm just going to multiply across here to simplify these two fractions. So that would now mean that I have x over 48, and that is equal to, well, I have a calculator, 1 1/3, so 4/3 times 7 is a messy number, 9.33, and 1 times 1 is 1, so okay, how would I get x by itself? I would multiply both sides by 48, and so x is equal to this number times 48, which is 448, which is close to 450, which is the answer. So mathematically, this is actually like the exact same amount of math that we did for that number 9. That was a much easier question, and that's because the conversion was much more intuitive. Minutes, I think, to seconds was what it was. Here we're dealing with a conversion that we've never seen before. Fields and acres and ounces, like it's a mess. But the system, our process, doesn't care that the story is more confusing because the process is consistent. The units need to match up. So that's why if you have a good process for these SAT questions, you're going to be prepared no matter what, because the SAT is obviously going to be different every time you take it. But the general versions of a lot of these questions are very, very similar. The process should work. So for ratios and units in particular, the process is reliable. So no matter what the test throws at you, when you see these unit conversion questions, you'll be able to handle them. And that's how you guarantee yourself points on every single test from mastering this kind of question.